Okay, so here, guys, let's go through assignment number 23 about all this good stuff here. So here in this problem, we got to graph the function. So then we'll go through the other stuff, I guess. Let me see if I have enough room here. I kind of never do these things with enough room. So I need to sandwich 2x between 0 and 2 pi. So for multiplying x by 2, let me get these out of the way. Hide those. I'm going to divide by 2 because that's the inverse of multiplying by 2. So I'm going to make an axis that goes from 0 to pi. I'm going to add the ends and multiply by half. So 0 plus pi is pi, times 1/2 is pi over 2. And 0 plus pi over 2 is pi over 2, times 1/2 is pi over 4. And I can see what I'm counting by. Each one is 1/4. So 1/4, 2/4, 3/4, and then pi. This is the y-axis. And then I'm going to be graphing cosine. So it's going to be up to, the beginning and the ends are up to, while the very middle is down to. And the middle of the middles are 0. I'm going to dot this graph in. And then the final graph is dropping everything down 1. And this is where I'm having that challenging part of dropping everything down 1. The amplitude, to answer the questions, is the absolute value of the coefficient, which is 2. The period is always, that should be there, that's 2 pi divided by this value 2, which is just pi. The maximum is the highest y, and that highest y is 1. And the minimum is -3. That's the lowest y the graph hits. And the midline is y equals -1. The midline is always your d value, which is your constant there. All right, in the next one, number 2, I'm graphing sine, so I'm going to sandwich 3x between 0 and 2 pi. Divide everything through by 3. And there I am. So it's going to go from 0 to 2 pi over 3. This is the beginning of that period. This is the end of that period. I'm going to add these, which is 2 pi over 3, times it by 1/2, which is pi over 3. 0 plus pi over 3 is pi over 3, times 1/2 is pi over 6. So that's 1 pi over 6, 2 pi over 6, 3 pi over 6, and that would be 4 pi over 6. Then the y equals 0. Sine curve. The beginning, middle, and the end are 0. The first half will be up 3, and that second half will be down 3. And then its final resting stop is down 2 units. So drop it down 2 units. And this is where I'm running out of room. And I should know better to try and tuck that in a small amount of space. The amplitude in this problem is this, which is 3, the absolute value of the leading coefficient. The period is 2 pi divided by this value, which is just 3. The maximum value is 1, and the minimum value is -5. In number 3, I'm going to take x over 4 and sandwich it between 0 and 2 pi. But to multiply everything by 1/4 means to multiply by 4. So, man, not much room here. And so I'm going to go from 0 to 8 pi. 0 to 8 pi. 0 to 8 pi is 8 pi. Half of it is 4 pi. Half of 4 pi is 2 pi. And half of 12 pi there is 6 pi. I can see I'm counting by 2 pi. And then I'm going to do this part first. So cosine means I'm going to be up 2 at the beginning, up 2 at the end, and down -2 of the middle. In the middle of the middles will be 0. But I'm going to dot that in because I'm not done yet. I have to drop everything down 2 units. And this is where it really gets hard because of the fact I didn't allow myself enough room. But it is evenly displaced vertically down 2 units. The amplitude is the coefficient of this, which is just 2. The maximum value, the highest y is 0. And the minimum, the lowest y, is -4 on my graph, which is down here at -4. And the midline is y equals -2. That's the line that cuts the graph in half, equidistant to the max and min. Oh, a little different. 2/3 x. 2/3 between what? 0 and 2 pi. So I'm going to times everything by its reciprocal. And I'm going to have 0. These divide out. So I'm actually going to go from 0 to 3 pi. 0 to 3 pi. What do? Add the ends and multiply by a half. So 0 plus 3 pi is 3 pi. Half of it is 3 pi over 2. 0 plus 3 pi over 2 is 3 pi over 2. And guys, when you times it by a half, you get 3 pi over 4. So you can kind of, you're counting by 3/4. So this would be 3/4, 6/4. The next one would be 9/4, and then 12/4, which is 3 pi, because each of these spaces is worth 3/4. And it's just an ordinary sine curve for the most part. So the beginning, middle, and the end are 0, up 1, and then down 1. I'm going to dot that in, and then I'm going to raise everything up this time by 1 unit. And man, you think I would have really done a lot better in planning the space there. The amplitude is 1. The maximum is the highest y value, which is 2. That's up here at 2. The minimum is down here at 0. And the midline is y equals 1. And I'm not sure if I said up here that the midline is y equals -2. All right, and the rest are all old problems really fast. 11 pi over 6. We should know that puts us here. This is pi over 6. -1, 2, √3. Cosines x over r are √3 over 2. Sine of 0, it's quadrantal. It's right here. The y coordinate 0. 3 pi over 2 is down here. That's 0 minus 1. Y over x, -1 over 0, is undefined. Sine of negative pi over 2 puts me here. 0, -1. Sine is the y coordinate when it's quadrantal. Pi over 3 puts me here. √3, 1, and 2. Sine is the y over the r. Tangent of 5 pi over 4, that's 1 and 1/4. Pi over 4 is here, 1, 1, and √2. Both of those are negative, being in the quadrant where both x and y are negative. Tangents the y over the x, -1 over -1 is 1. Sketch a graph of the function. The vertex here, guys, is 0, -2. And when x is 1, y is 1. And when x is -1, y is 1. And I also have my minimum value there because it's concave up. The minimum is -2. Some pretty cool factoring ones. This is a difference of 2 cubes. Just take the cube roots of both, square the x squared, multiply these, but change the sign, and square the last. Here I'll begin by taking out an x, and then I will do a difference of 2 cubes. Here, this is a difference of 2 squares, CD minus 4e squared times CD plus 4e squared. That is a difference of 2 squares, not 2 cubes. This one you can view as either a difference of 2 squares or 2 cubes, because it's both, because 6 divided by 3 is 2. So I can do x squared minus, if I divide that by 2, I'll get x cubed minus 1 and x cubed plus 1. And man, this is a good one. This factors into x minus 1 times x squared plus x plus 1. And this factors into x plus 1 times x squared minus x plus 1. So the bottom line is what I did was, this is a difference of two squares. And the square root of this is x to the third. The square root of this is 1. So it's x cubed minus 1 and x cubed plus 1. But then each of these is a difference of two cubes. That part's here. This is a sum of two cubes, and that part's there. And here finally our number line test on these inequalities. The critical points are -2 and 1. Everything's an open circle. If I pick -10 as a test point, that's -11 squared is a positive times a -8 is a negative. If I pick 0, pick 0 as a test point. 0 minus 1 is a -1, squared is a positive, and 0 plus 2 is a positive. And then if I pick, say, 10, I'm also going to get a positive. So where am I greater than 0? -2 to 1, and 1 to infinity. Remember, at 1, the power is even, so the number line should not change signs. Only on the odd multiplicity should the number line change signs. And the very last problem is I'm going to factor this into x minus 3 and x plus 2. And the critical points are -2 and 3, closed circles. I already know that this is a parabola that's concave up because of the x squared. So it's going to be positive, negative, positive. The powers on here are odd, so it has to alternate signs. So where am I less than or equal to 0 is where the number line is negative. Bracket at -2, bracket at 3. Remember, the number line is not the answer. It's the interval notation. Extracting the critical points from the number line, that is your answer. So again, this means my parabola is concave up, because the positive leading coefficient, it hits the x-axis at -2 and 3. So of course it's first going to be positive, then negative, and then positive. So my final answer is from -2 to 3.